Hello, my name is Alex Hafner and I am the Strategic Insights Manager for the ESO. This session is all about FES 2020 scenarios and how they have incorporated the net zero decarbonisation target. I'll be presenting for around 20 minutes and will then be joined by my colleagues Rob and Shabor for the Q&A session. Okay, before we start in earnest, I want to give you a very quick run through of what I'll be covering today. We'll kick off with a quick run through of the key insights from the presentation. I'll then explain what we mean by net zero, both in general terms, but also specifically in relation to FES 2020. I'll then introduce the FES 2020 scenarios themselves, and then, having set some context, I'll briefly introduce some of the results of our analysis in terms of carbon emissions and energy flows. Finally, I'll touch on some key uncertainties before launching into the Q&A session. I'm going to start by sharing some key insights around net zero and the FES 2020 scenarios. Now, don't worry if these seem slightly out of context to begin with, as we'll revisit them at the end as well, after I've been through all the material. The idea is that by being aware of these 4 points from the outset, it will help you focus on the messaging as you navigate the sessions later today and tomorrow, as well as through the FES 2020 document. The first key insight is that 3 out of 4 scenarios meet net zero by 2050. Now, this is less of a modelling result, as it's a fundamental part of the scenario framework for FES 2020 that I'll be talking you through later. However, it does highlight the clear signal of intent that the new net zero target provides to FES. The second key insight of this presentation is that a whole system approach is needed for net zero. I'll go into more detail around exactly what we mean by whole system on a later slide, but the takeaway here is that net zero won't be achieved by considering different sectors individually. Instead, understanding the cross-sector interactions and harnessing the benefits that they bring will be crucial as the economy decarbonises. Thirdly, meeting net zero relies on changes across society. Even though this is something that we discussed at length with stakeholders when we were deciding on the FES 2020 scenario framework, it became increasingly clear as the analysis developed just how many of our assumptions were linked to consumers changing how they use energy. This doesn't mean that everyone suddenly becomes much more environmentally aware overnight, or even that there is a much greater understanding of where their energy comes from. Instead, it's that consumers embrace new technologies like EVs and heat pumps, and engage with new ideas that have the potential to improve their way of life and reduce their bills, whilst also supporting operation of the future energy system as it decarbonises. Finally, our analysis has shown that technologies like hydrogen and carbon capture, usage and storage, or CCUS for short, are required in all net zero scenarios. CCUS is a critical technology because it offers the ability to generate negative emissions at scale. Some sectors cannot remove all of their emissions, and so a means of achieving negative emissions is required to meet the net zero target. It will also become clear when I introduce the energy flows we expect to see in 2050, the importance of hydrogen, even in very electrified scenarios. So hopefully that gives you a little bit of a taster before we dive into more detail. As I said before, we will revisit these key insights at the end of the presentation. So what is net zero? In June last year, just before FES 2019 was published, as it happened, the UK committed to a more ambitious target for reducing its carbon emissions. This target requires the UK to reduce greenhouse gas emissions to net zero by the year 2050. Net zero means that any residual emissions need to be balanced by schemes that can offset an equivalent amount of greenhouse gases from the atmosphere. We've identified sectors where it does not appear possible to completely eliminate all of the greenhouse gas emissions, and so these negative emission schemes will be required. Examples of negative emissions include land use changes like planting new trees. However, we've also focused on technological solutions like bioenergy with carbon capture and storage, or BECCS for short. The new net zero target is in contrast to the previous government target, which was set in 2008, and which was a reduction in greenhouse gas emissions of at least 80% compared to 1990 levels. This previous target was the basis of FES2019, but it left a 20% chunk of emissions that many sectors thought could apply to them. The new target removes this ambiguity straight away. The combination of the points above means that it's vital for FES2020 to cover the whole of the UK economy, not just the energy sector, and certainly not just electricity and gas networks when we consider emissions. The diagram on the right is a way of exploring what we often refer to as the whole system, as emissions from across all sectors have to be considered in the net zero calculation. The next slide looks at the three aspects on this diagram in slightly more detail, especially the interactions between them. FES2020 must reflect the legislated target of net zero emissions by 2050. And to do this, it's really important to focus on whole system interactions, which can be considered at three different levels. The first is networked energy, and you can see this in orange on the right-hand side of the diagram. By this, we mean energy that is transported from where it is produced to where it is consumed using networks, such as electricity or gas, that interact strongly with each other every day. For example, gas-fired electricity generation. The second is all energy, which you can see in blue in the middle of the diagram. This includes areas where energy demand is met outside of the network's energy system, such as by oil or petroleum-based products. This demand may potentially be met by the networked energy system in the future, for instance, as the transport sector decarbonises. And then the third category is the whole economy, which you can see in purple on the left-hand side of the diagram. This includes everything, including non-energy sectors, but which have a direct impact on energy decarbonisation. This can be seen most clearly in the complex role of bioenergy and the corresponding land use implications, but also includes how societal change impacts energy and emissions. The value of whole system coordination and co-optimisation increases as you look at the interactions from left to right on the diagram. Some of these interactions will play out in investment timescales, such as the transition of road or maritime transport from fossil fuels to zero carbon networked electricity or hydrogen. Other interactions, however, will be seen in more operational timescales, such as changes in the amount of biomass, natural gas, or hydrogen that are used at any one time to generate electricity. FES2020 considers energy use in sectors that haven't been included in our analysis in previous years, such as shipping. We also consider emissions from non-energy sectors, such as agriculture and land use change and forestry, or LUCF for short. For these sectors where we don't have deep expertise, or where we do not yet have strong stakeholder evidence, we use inputs from published CCC analysis and engagement with their experts. I'll now go on to talk about the FES20 scenario framework, and if you want to know more about this topic, check out the Net Zero thought piece that is appended to this year's FES document. Now, the reason why a clear understanding of net zero is important is that it is at the core of our new scenario framework. This was developed alongside stakeholders and was published in our stakeholder feedback document in February earlier this year. The speed of decarbonisation axis, which is along the bottom of the screen, was retained from last year's framework, but the placement of the scenarios along it has shifted to the right. This is because net zero really is a game changer, and whilst two scenarios in FES2019 met the old 80% reduction target, we now have three scenarios that meet the new net zero target by 2050. We saw earlier how net zero broadens the scope of FES, and this is one of the reasons we agreed with stakeholders that a new level of societal change axis should also be applied to the FES framework, and you can see this up the left-hand side of the page. This is because it better allows the uncertainties around net zero to be explored than the previous level of decentralization axis. What we mean by societal change in this context is the level of behavioral change that can be assumed by the end consumers of energy, whether these are domestic consumers, businesses, or heavy industry. Importantly, it includes changes that are mandated, as well as those that are made on a more voluntary basis. The scenario framework is the basis on which all of the FES analysis is developed, as it supports high-level assumptions all the way through to detailed modelling levers. Throughout the presentations this week, and in the published FES documents, you'll see these 4 scenario colours repeated across the charts and infographics that describe the results of FES 2020. I'll now go into a bit more detail on each scenario, starting with consumer transformation. However, if you're interested in the scenario framework, more detail can be found in the stakeholder feedback document that I mentioned earlier, and there's also an explanatory blog which sets out why we develop these scenarios in the way we have. Both of these are available on the FES website. Consumer transformation, which is the orange box on the framework, is an electrified scenario that meets the net zero target in 2050. Heating is largely provided by electric heat pumps, and to support this, there are high levels of thermal insulation in buildings. In addition, end consumers are willing to change their behaviour, and so this facilitates a high level of demand-side flexibility. For example, smart charging of electric vehicles. System transformation, which is the blue box on the framework, also meets net zero in 2050, but it does so in a different way. Rather than electrification, this scenario focuses on hydrogen for heating and industry. As it is lower down the societal change axis than consumer transformation, end consumers are less willing to change their behaviour. This means that a great deal of the decarbonisation effort is seen on the supply side, so that the impact on consumers is lower. Leading the way, the green box has the highest level of societal change and is the scenario that represents our fastest credible decarbonisation. It has the highest levels of energy efficiency and employs a mixture of hydrogen and electrification to meet net zero. Steady progression, the grey box, has the lowest level of societal change and also represents the slowest credible decarbonisation. Similarly to FES 2019, this scenario sees progress made in decarbonising power and transport, but not heating. Now that we've covered net zero and the new scenarios, we can look at some of the results of FES 2020. This slide shows how greenhouse gas emissions fall in the years between now and 2050 in our analysis. This is a high-level chart just showing the net path for each of the scenarios, as highlighted by the colours we discussed earlier. A more detailed view on an individual scenario basis can be seen in the main FES document. We begin in 2019 at a level of 480 megatons of carbon dioxide equivalent, which is reduced from 1990 levels of 818 megatons of CO2 equivalent. Emissions fell an average of 19 megatons each year from 2008 to 2018, and must still fall an average of more than 15 megatons each year from 2018 to 2050 in order to meet the net zero target. Remember that the chart shows net emissions, and some sectors, such as power, are already negative in the net zero scenarios by the mid-2030s. So, looking at the scenarios individually, steady progression in grey doesn't meet the target and still emits 258 megatons in 2050. This reduction of 68% on 1990 levels is far from net zero. But the dial has moved on slightly from the steady progression and consumer evolution scenarios in FES 2019, which both only got down to 58% of the 1990 levels. Leading the way in green, on the other hand, reaches net zero in 2048 and continues to decrease after this point, although the rate of reduction slows from around 2045. consumer transformation and system transformation, in orange and blue respectively, both meet net zero in 2050. This is as per the scenario framework, as the modelling goal seeks this outcome, and therefore it's less of an analytical result. In fact, as the net emissions trajectory of the net zero scenarios is largely similar over the next 30 years, it's really helpful to look at what our analysis shows regarding the energy flows for these scenarios. This energy flow chart, sometimes called a Sankey diagram, starts off on the left-hand side by showing the different input energies into the energy system. This particular diagram is for the orange consumer transformation scenario, and it represents the year 2050. You can see natural gas at the top in the dark blue, biomass in brown at the bottom, and various different types of electricity generation in the middle in orange. Then, on the right-hand side of the diagram, you can see the different groups of energy end consumers. For example, you have sectors like industrial and commercial, residential, and transport. When it's all brought together, you can see how input energy is transformed as it moves through the system to the end consumers. As this is consumer transformation, a lot of the energy flow is in the form of electricity, but you can still see both electricity and natural gas being converted into hydrogen, which is the light blue, for use in all the major demand sectors. By way of comparison, I'll now quickly switch over to the system transformation version of this diagram, again for the year 2050. You can see straight away that this scenario produces a far greater amount of energy as hydrogen, which is mostly produced by reformation of natural gas with CCUS capturing the emissions. This emphasises the importance of these technologies. You can also see that the total amount of energy in this scenario is greater than consumer transformation, the one we looked at before. This is as a result of system transformation having lower levels of energy efficiency than consumer transformation. The FES document contains similar diagrams for the other two scenarios, the green leading the way scenario and the grey steady progression scenario, as well as more detail on energy supply and demand across all scenarios. Now, as promised, I'll quickly revisit the key insights. So this is just a reminder of what the key insights were at the start. Hopefully, the material that we've covered since has helped bring these to life slightly. Firstly, in the top left corner, exploring the FES2020 scenario framework showed how 3 scenarios now meet the net zero target by 2050. Then, in the top right corner, discussing the whole system diagram showed how FES2020 is wider in scope as a result of net zero, and therefore that a whole system approach is needed. Thirdly, in the bottom left corner, the use of the societal change axis in this year's scenario framework highlights the importance of behavioural changes of consumers in understanding the path to net zero. This theme, along with energy efficiency more generally, is the basis of the consumer view chapter of the main FES document. And finally, in the bottom right corner, the energy flow diagrams we just looked at highlighted the importance of both hydrogen and CCUS in meeting net zero. This can be seen in much more detail in the system view chapter of the main FES document. Finally, before we move on to Q&A, I've listed some of the remaining uncertainties that we will be continuing to explore in our follow-up work to FES2020. These may help form the basis for questions in the Q&A session. The first area of uncertainty is around carbon accounting. FES currently uses the same method as the likes of CCC and government, in that it looks at direct emissions within the UK. However, in the future, this may be broadened to consider things like offshoring of emissions or upstream emissions associated with UK consumption. There is also an open question around whether an international carbon market may be formed and what impact this would have on the scenarios and UK decarbonisation. Then, building on the key insight around hydrogen and CCUS, there was a question around what happens if there are delays in the development of CCUS. A similar question can be posed in relation to data and digitalization, given the assumptions around smart appliances and time of use tariffs in our scenarios. Then, there's the potential long-term impact of COVID-19 on energy supply and demand. FES2020 does not model this, but we will be carrying out follow-up work later in the year on the subject. Related to this, there is also the potential for a green recovery from COVID impacts, and whether there will be policy change in the energy industry to support this, especially in light of the UK hosting COP26 next year. We'll be sharing work on the costing of our scenarios later in the year too, just as we did in FES 2018. And finally, perhaps the biggest uncertainty of all, and certainly related to all of the others above, is the level of societal change that can be assumed. Reaching net zero will not be possible without changes to consumer behaviour, and FES 2020 tries to capture this uncertainty by using the societal change axis. Okay, thank you for your time, and I'll now hand over to Lauren for the Q&A.